Hey, what's up everybody? It's Mike from Cornfield Customs and I am back in the shop working on the 1940 Cadillac Lasalle. So this week I need to make some sections of the top of the door frame from where the roof came down. The top of the door got a little bit wider to accommodate the opening. So we are going to make the tooling for the Linux to make new door tops inside and out. So we'll do the inner structure and the skin. So in this video, we're gonna go through casting molds, making the tooling, and making the sheet metal profiles we need. So stick around. So just like with making the tooling for the center peak on the underhood piece on the 60 Cadillac, we're going to do a similar process with kind of building up a dam using some clay and pouring some body filler to cast a good section of this profile. That way we get the outside of the door and then where it rolls in into the trim and the window seal channel, and it'll give us a nice flange that we can spot weld back together to the inner structure. And then from there we will flip it over and we will make the same thing for the inside. So we'll build a clay dam, pour some body filler to make a mold, make the tooling, and then we can use that in the Linux as well. So first things first, I'm going to take some cardboard or some chipboard and kind of clamp it here underneath and here underneath. That way it gives us a lot more surface that we can pour our filler and we don't have anything leaking down and we get an accurate casting of the part we need. So I'm going to select a good section of the profile we need, and right about here it looks relatively straight. Up here just has a little bit more curve than I would like because this kind of curves and then it starts to straighten out. So I think we'll get a better reading right here in this area. So I've got some just some pieces of chipboard here and I'm going to clamp those into place, and I'll end up putting a little bit of tape on the back side of that as well just to help hold it in place a little bit better where the clamps don't reach, but the clamps will keep it there until I can get everything taped in. All right, so here I have some air dry clay. In the last video I ended up using just some Play-Doh because I was out of clay. So we've got that here. I'm just kind of kneading it up a little bit, getting it warm in my hand so it's a little bit more pliable and everything's nice and consistent. So we'll tear off a piece, and I'm looking to cast right about here. So what I'll do is just kind of press the clay into place where the profile is that we want to cast our mold of. And I'm going to make it a little bit wider and a little bit longer than we actually need it to be, because we can always cut the filler mold down. I'd rather have too much than not enough. So there's kind of our clay dam. I added a piece of sheet metal to clamp under there just to help support the chipboard where the weight of the clay was kind of pulling it down. So we're not looking for the statue of David or some crazy sculpture. We just need to build a clay dam around the profile we want, and then we're going to use body filler to fill that up. So that's what I'm going to do next, is grab the can of body filler and the hardener and some fiberglass resin so we can thin it out and make it really runny. So I'm going to put some rubber gloves on just to help keep the body filler off my hands because it tends to make a mess. I mentioned it in the last video that this is just some cheap filler. I don't really remember where I even got it, but it doesn't matter because I'm not looking for long-term quality of using a name brand filler or anything like that, because all we're doing is using this is a casting medium to cast the profile for the tool we need to make. So in the last episode that I did where I cast a mold, somebody came by, I'm guessing that they were a chemical engineer, and they were telling me how I mixed everything wrong and that I can't add fiberglass resin to body filler with body filler hardener. Well, guess what? Cool your jets, because this is a common practice in the auto body field. And again, if this cracks in 6 months, I don't care. because all we're doing is thinning this out with the resin to make it easier for us to cast the mold so everything flows down into all the corners. So cool your jets, it works, it's fine. Move on with your life because it's not the end of the world. So I'm kneading our hardener here. That way it's all mixed up. And if I was super worried about it, I could weigh everything for the mixing ratios, but just kind of eyeballing it here. And now we'll come over with our filler and we will start to squeegee some in to our clay dam area here. Just kind of dumping it right into place. I've sprayed a little bit of mold release inside the clay dam mold area. That way it'll be easier to get this out once it cures. And you can see that thinning the filler out really makes it nice just to kind of dump it in here and let it self-level. So that is the key to using the thinner or the fiberglass resin to thin everything out to make it nice and easy to pour. So from here, we'll just let that harden up and then we can pop everything loose. Now that I dressed all the edges on the belt grinder, everything can be test fit. I went ahead and labeled everything that it's for the 1940 Lasalle, driver door tops, and I dated it. So we can come over to our section. We can test fit to make sure that everything looks good. And from there, we can start laying it out onto our bar stock and machine it to make the tooling. So here is the material we're going to be using, just like on all my other tooling. It is 3/4 by 3/4 square, 1018 mild steel. We do not need to use tool steel for our profile tooling because it's such limited use and we're not actually hammering on it super hard. So in reality, I'm probably only going to make this filler piece and then the filler piece for the passenger side, and that might be the only time these profiles are ever used. So there's not really much of a need to use a higher carbon steel or a tool steel with the additional expense and additional time required to machine. So 99.9% of the time, standard 1018 mild steel works great for Pullmax or Lennox style profile tooling. So I'm going to go over, spray some die chem on here, and then I can lay out our profile, get it set up in the Bridgeport, and start rough cutting out our profile using our cast mold piece of the door top. with both tools being machined, the female and the male side, and I went ahead and I welded on the stems that will put it and hold it into the Linux. I used our alignment fixture that we've used in other videos. So everything is machined, filed, and the stems welded on both pieces. So then what I did is I came in and I applied die-chem to the face of both male and female tool. And I came in with a compass and I made a scribe line about 3/16 of an inch inward, and that will be for our lead in and our lead out. So on our male die, I've went ahead and started that process, and on this side I've just used a carbide burr tool, and I started roughing our lead in and lead out on the piece. This side I've come back and started finishing it with a file. So what a lead in and lead out does is as the metal comes in and passes through the tooling, you have a lead in, and that will keep the edges from digging in and marking the metal, and same thing when the panel passes out the back. So the more aggressive the tooling, the more of a lead in and lead out you will need on your tooling to prevent those tooling marks on your panel. So I'm going to get back to clamping these in a vise and working on getting the lead ins and lead outs dialed in, and then we can get everything sanded with 80 grit, and we can do a test and see how the profile looks, and anywhere we need to refine the tooling to remove any tool marks that we find in the test. Now that our tooling is all filed and fit, I went ahead and put it in the Linux, and we're going to run a test. I also went ahead and I just welded a flat piece of 1/4 inch plate steel to the back as our guide. That way we have something to push the piece of material up against as we work it through the tooling. That'll come into play a lot more once we cut the curvature of the piece we need for the door top. So now that it's in here, we're gonna run a test piece and we'll see how it goes. And the process of that is I'll turn the machine on, and the upper die will move a little bit at a time. I have it set right now to run about 80 thousandths to 100 thousandths up and down. And then I will slowly move the lower tool up by adjusting this handle here, and that'll raise the lower tool up and tighten our gap between the upper and lower tool, and that will put our profile in it. So let me grab a piece of sheet metal and we'll do a test and see how it turns out. So I've got the test piece here that we just did on the Linux. I'm gonna set that here for now. So with our test piece, I went ahead and put the correct radius in the test piece itself, or the arc that matches the top of the door frame. And how I did that is I took our sweep here and I found a sweep that matched up to the radius we wanted to use. And in this instance, it was a number 19. So if I hold it here, I can check it across, and before the radius increases as it comes down the A-post, where the opening is and tying into the front is pretty much spot on a 19 sweep. So that's what I laid out our front edge to. So there is a little bit of an arc to this piece, and now we can test fit it to the door. Here's our test piece, and the good thing about doing a test piece is you can look for tooling marks kind of like this. You can see it, but you really can't feel it all that much, and it's going to be right where we're going to turn this edge anyway. So I left it long, and we'll just kind of sit it on there and see how it initially fits. There's a little bit of a gap here, but I think it's where I kind of fed it into the machine, but having plenty of extra, that helps get it centered. And this is a little long, but that's okay. I'd rather have too much than not enough, and I can come and trim that. And this is a little short for the hem edge. So this is one good reason why I like to do a lot of test pieces, just to ensure that I make sure everything lays the way I want, it's the same profile, and that I have enough material where I need it. So I'm going to add about 1/4 of an inch to this edge when I make the actual part, and that will leave me enough material that I can fold that edge over for the hem. So I think overall this is pretty good, and especially for our test. So now I can lay out our final pieces, get those cut and filed, and we will make the real part. So now I'm set up, and I'm going to lay out to cut our blank for the final door top of the Lasalle. So I'm going to move the camera in a little bit so you can see what I'm doing with laying out the radii that I've picked with our sweep. The first thing I'm going to do is I'm going to take our sweep, which it's a number 19 sweep right here, and I am going to lay it at the bottom of our piece of metal we're going to use. And I'm just going to trace this radius onto our panel using an ultra-fine Sharpie, and then I can set our sweep to the side. So from here, I've decided what thickness or width I want this to be. So I'm going to use 3/4 inch masking tape to offset that line on the panel. So I'll just take our tape, like I've done in numerous other videos, and use it to offset our radius. And I've decided that I'm going to use 4 rows of masking tape to offset the edge. That way it gives me plenty of material left for the hem edge and a little bit on the spot weld side of the panel. That way it can be trimmed to fit afterwards. I'd rather have a little bit of extra than not quite enough. So now that that is laid out, I actually kind of don't like this line so much. So I'm going to address that, tidy our line up just a touch, and I'll come back and clean this line up to match. Then I'll take our ultra-fine Sharpie again, and I'll mark this, and that will be our cut line. With our piece nice and filed and smooth, I'm going to head back over to the Linux, and we will go ahead and put the profile in this piece. So this section of material is actually long enough to be both the left and right hand side if I cut it in half. One thing I found with doing a profile tooling is every once in a while you get a little bit of deformation where your part enters and exits the tooling where you start and stop. And mainly that's because it could run off the edge of your back gauge a little bit. So this is plenty long to do both left and right, and I can trim off the outside edge and then cut it in the middle, and I will have a left and a right hand side piece. So I'm kind of doing that to save time and limit how much deformation I get at the ends. So let's head back to the Linux and we'll get this thing knocked out. So just like I did in our test piece, I'm going to lower the lower tool post down, and that will be plenty of a gap to get started. I will run our piece through, I'll increase the lower tool post up just a little bit, tightening our gap, and just work it back and forth as many times as it takes. We're not in a hurry. If you get too carried away, especially on more of an aggressive profile like this one, it can leave tooling marks and chatter marks. So take your time, don't get in a rush, and just let the machine do the work. If it takes an extra 5 minutes, but you get a nicer part, to me, it's worth it in the end. Let's get to putting this profile in. Our part is done in the Linux. With the additional material I added here for our hem edge to be folded over, it kind of left a little bit of a tool mark. I think you could see it in the video of me running it through the Pullmax. So the good thing is where it's located is almost right where the hem edge is going to start to fold under, but I want to correct that now just so I don't have any issues later on down the road with it. So what I'm going to do is I'm going to head over to the Milwaukee Air Planisher, and I've got a rectangle die in the bottom of it, and I'll just planish that line out, get everything blended nice and smooth. That way I don't have to worry about trying to correct it if it becomes an issue later on. So let me head over to the Planisher, we'll get this addressed, and then this piece will be all wrapped up. All right, so here is our finished piece. I planished it a little bit, and then I ran over this top bit here just with a Scotch-Brite just to even out the texture. Where I was planishing it, it shined it up just a little bit. So just to make everything even, I ran over it with a Scotch-Brite. So here's the front side, and I'll turn it around, and there's the back side. So at this point, I just gotta trim the edges, both sides, and I can cut it in the middle, and then it'll fit on the door top. I'll go ahead and sit it on here just so you can see it, but also I'm gonna do a close-up kind of pan over it, front and back, at the end of this video. So hopefully this is kind of informative on how I do things like that. Again, I've done other videos on profile tooling and making things like this. I just thought this was a good one because it's a little bit more complicated of a profile and it has an arc throughout. So that's gonna wrap up this video. Hopefully you guys enjoyed it. I really enjoyed making it for you. So let me know what you think. Drop down in the comments section, leave me a comment, share with your friends, share on Facebook, Instagram, anything you can do that'll help me spread the word of this channel. I'll keep pumping out content that I think you guys will like, but if you leave me a comment of what you want to see, I can try to do my best to cater that towards what you guys are after. Again, I mentioned a few videos back, if you're struggling with any metal shaping project on your own, shoot me an email and I will do my best to answer it in a video format of your video and my solution, but it has to be a part that I would be able to duplicate, or I'm gonna try to group them together if it's not something super complicated that I can talk through, and maybe we'll do like a 4 or 5 sit down walk through the solution on what I think would be the best route to move forward on your project. So if that's something that suits you, my email is going to be in the show notes, so check that out. Email me a video of your project and I'll do my best to do a solution video for you. So again, thank you guys so much for watching. All the support is greatly appreciated. And like I said, drop down in the comments section, give me a like, give me a thumbs up, and I'll keep pumping out the videos and we will catch you guys on the next one.